Good morning friends. In this video we are going to see what is return bend and when we need return bend and hydraulic calculation design mistakes related to the design return bend. I mean, what are the fittings we should consider if we have return bend and what are the fittings we should not consider if we have the return bend in the hydraulic calculation. So as you see here in this image, return bend has the concept like it will have one riser nipple and it has one arm over is the horizontal piping, then we have the drop. Okay, so this one we need to understand where the first of all we need to understand where the riser nipple will come, so we can understand the purpose very clearly. So for example, here you can see we have the fire pump here. So here I have shown the residual path or longest path. So for example, from the fire pump we have the vertical riser line. Here we have the alarm check valve assembly, and there are number of floors are there. Let's say that we have 5-floor building. So there are 4 different floors are there, and 5th floor is the longest path for us. So we can say residual path. So this is the last 5th floor branch line, and here you can go to the like you can say the air vent will be there in the last floor in the riser. So this is the last floor, and I have taken the branch line. So here you have the zone control valve assembly, and this line we can say like a cross main. Okay, we can say it's a cross main line. From the cross main I have taken the branches, like I have taken left side, also it will be right side. So these 3 branches I have shown only the residual path or longest path for the hydraulic area. So here if you see at this point, I have taken the line using the riser nipple. From the cross main I have taken it up, then again I have taken two branches line. So here I might take like from the cross main I can take the same level. For example, this is your cross main section pipe. I can take the same level from the bottom, but I didn't do like that. What I have done, I have taken from the up. So I have used one riser nipple, then I have taken 2 side branches. So now in this case, let's say that this is your corridor line. So we have the corridor. So from the corridor I am supplying to the branches. There are different branches are like this. Suppose in your case, in the corridor you have to provide the sprinklers. So corridor has this ceiling. So what we will do, from this ceiling, from the same cross main, for example from the same cross main, I will take one pipe up, then down, the straight and down. So here I will provide the pendant sprinkler merging the ceiling line. So this is the return bend which I showed you. So here in this case, instead of providing the return bend like this, you have the another option. For example, you can provide the line directly down like this, but this installation directly down from the cross main is not acceptable. So now we need to understand why I have considered the return bend like this arrangement if I provide the line directly from the cross main. But when it comes to the branch main, for example here you see I have taken the riser nipple. So from the cross main I have taken up, then I have considered the branches line. So here for example if you want to install one pendant sprinkler, here you don't need to provide the return bend in the branch line, but here you have to provide the cross main, you have to provide the return bend. If you understand what are the conditions you need return bend, then you can understand very clearly about the calculation. For example, return bend, the return bends shall be used where the pendant sprinklers are supplied from a raw water source or open top reservoir or mill pond. For example, you have the open reservoir, from there the water is supplied to the sprinkler system. So that time you have the pendant sprinkler bin, then you have to provide the return bend, because if you are supplying the water from the reservoir, there will be some dust, air particles, dust particles and dirt particles, there are different things will come. So that will block the sprinklers, because sprinkler orifices are very small. So to avoid the blocking of this one, if you are taking the water from the reservoir and this type of thing, then you have to provide the return bend. So normally what happened, from the municipality water, this water will be collected in the firefighting tank. From the firefighting tank, using the fire pump, this will be distributed throughout the system. So if you have any dust particles in that water, so that will be going to the firefighting system. And for example here if I take the connection from the cross main directly like a pendant line, you know that in the pendant sprinkler it has a very small orifice sizes. For example, if you see this one, the orifice opening at this one, you can see the orifice opening, the sizes are very small. So if you have any dust particles, if they block the pendant sprinkler, then at the time of fire we cannot see the water coming out from the sprinkler. So that is the reason if you are taking the line directly from the cross main, you must take the line through the return bend. So if you are taking the line branch from the top, if you have the dust particles in the cross main, that will be settled in the bottom of the cross main only. For example, it will be settled in the bottom only because you are taking the line from top. So that is why if you are taking from cross main, you have to provide the return bend. When it comes to branches line, you are already taking through the riser nipple, so you are making the up, then you are taking to two-sided branches. So this time if you want to install the pendant sprinkler, you can directly install through the down. You don't need to provide the return bend if you are taking already the branches line in the up like this. So the first point is clear. Coming to the second point, return bend shall be connected to the top of the branch line. So this one, as I explained, we have to consider the line from the top one. So here you see we have to consider the line from top of this arrangement. So this is what explained here. And coming to the third point, here you can see return bend shall not be required for deluge system. So what they have mentioned, normally we have four type of system like wet system, dry system, deluge system and pre-access system. So deluge system has the open sprinkler. So for the open sprinkler, we don't need the return bend. And coming to the next point, return bend shall not be required for dry pendant sprinkler. So this is one of the important thing, because normally the dry pendant sprinkler, like you see here, I have taken one Tyco data set. So this dry pendant sprinkler, we don't need to provide the return bend. So this is the concealed pendant sprinkler. Just for the sample I have shown, like this is the dry pendant sprinkler. So the dry pendant sprinkler, again we don't need a return bend. So the next one, the final one here, return bend shall not be required for the wet type system if the K factor is 11.2 or 160 or higher. So if you see the Nfpa, there are different K factors are available starting from 1.4 to maximum 28. So they have mentioned that if the return bend doesn't need, if the wet system, if the K factors are 11.2 and higher. So this is the important thing, because mainly because of the higher orifice size or opening size. If it is more than 11.2, then we don't need to provide the K factor for the wet system. And the next important thing is, when we go for the hydraulic calculation, should I consider all the fittings in the return bend? So the answer here is, for example, this is the cross main line. From the cross main, I have installed one T and I have taken it up. So this is called as a riser nipple. So if you see the definition of the riser nipple, for example, as per the Nfpa 13, so a riser nipple is defined as a vertical pipe between the cross main and the branch line. So when we go for the calculation, we have to consider the riser nipple, I mean this pipe, and also this elbow, 90-degree elbow, and this arm over this pipeline, and again this 90-degree elbow and the drop. So all these fitting we have to consider when we go for the hydraulic calculation. And another very important thing in the hydraulic calculation is, for example, now we have the cross main. So if as I told you, if I want to provide one sprinkler in the corridor, so I have installed return bend. So all this fitting I will consider. And when it comes to this point of view, for example, you see here, this is the cross main. I have taken the riser nipple. So here I have taken two bend. So here also all the fittings same like a riser nipple, the bottom T. And for example, if you zoom this section, it will be like this. So this is your cross main, line, and here you have one T, for example. So this is the riser nipple and another T. So these all fittings you have to consider in this arrangement. And comes to the sprinkler, you can see there is a bottom of the sprinkler, there is a small pipeline. So this pipeline is called as a sprig pipeline. So a sprig means a pipe that rises vertically and supplies a single sprinkler. So in our case here, like you see here in that, as like I showed in the drawing, you have to consider this pipe, the vertical pipe which rises from a single sprinkler, that is called as a sprig pipeline. So this pipe also you have to consider for the hydraulic calculation. Because most of the time this sprig pipe is not considered in the hydraulic calculation. That is a very important mistake. So you have to avoid this one. So I hope now it is very clear for you what is return bend and what are the fittings we have to consider in the return bend, and mainly the design calculation mistakes like the sprig pipe and the riser nipple. So all these fittings also we have to consider the return bend. So thank you for watching the video. We will see you again with another interesting topic.